Hello dear colleagues, and welcome to my short presentation for EGU 2020 HS4.4 session. My name is Alperen from Ankara, Turkey, and today I will demonstrate a short presentation about our project with co-authors shown here, Mehdi Avşar and Burak Bulut. Our title is Short-Term Hydrological Forecasting for a Cascade Dam System, a case study of Euphrates Basin in Turkey. Few years ago, I have been asked to develop a dam inflow forecast system from a private company, and we have started developing since the end of 2018. We still have a long way to go, and I personally want to get comments and suggestions for our project on EGU. Firstly, I will talk about the study area, then I will talk about model structure, and lastly, I will give some recent summary results. Now let's move on. Our study area is located in eastern Turkey on Murat River, which is the major subsidiary branch of Euphrates River. And on this branch, there are 8 dam projects over 25,000 square kilometers area. Some are on operation, some on construction, and some on project stage, which will be shown soon. The employer company owns 6 of these projects shown with green markers. 2 other dams shown with orange are both on upstream, one in operation and one in construction. Our study area includes 3 dams, 1, 2, 4 in operation and 3 in planning, dams 3, 5 and 6. Since dam number 2 is recently started operation as it can be seen on the map information, I will only present results for dam 1 and 4. Now let's move on to the model structure. Our system has 2 major components, model scheme and forecast scheme. As a hydrological model, we have used HPV. As we inspected similar systems, HPV was one of the most used models because of its ease of use and computing speed. We have chosen 5 natural stream gauge stations and 3 weather stations around our basin and calibrated them for 30 years period. Then we used the same station data for validation for the next 10 years. And in the end of this process, we have obtained our stream gauge station forecast scheme. On our forecast model, we input NOAA's GFS weather forecast as input since they are easily accessible, and then we obtain 16-day-long flow forecast for stations. On next part, we have decided to simulate mid-basins between each cascade facility rather than the bulk basin for better accuracy, and by using those forecasts, we least square fitted the data into mid-basins. We also perform weekly volumetric corrections to signify the seasonal trends better. As a note, we are still developing temporal correction algorithm to increase the time accuracy. And in the end, we obtain facility inflow forecast by summing up the mid-basin forecast to upstream facility outflows. Here, I will show you example time series of actual flow and prediction for 60-week duration for 2 dams we have inspected. As you can see, while we obtain high correlation between our datasets, our Nash-Sutcliffe values remain low. And as we inspect, the main reasons of these statistics is temporal mismatch. As I told earlier, we are still trying to develop a proper temporal correction to our system. And for this, actually we have to wait because we need facility data to accumulate to create a better understanding of cascade link on our model. We only have 2-year-long data since the facilities are relatively new to operation. As of 60-week data, for dam 1, clustered correlation is 0.96, maximum weekly correlation performance is 0.94, clustered Nash-Sutcliffe index is 0.92, and maximum weekly Nash-Sutcliffe performance is 0.86. And for dam number 4, the clustered correlation is 0.90, maximum weekly correlation performance is 0.91, clustered Nash-Sutcliffe index is 0.82, and maximum weekly Nash-Sutcliffe index is 0.37. As I told, right now we are only being able to create these results with 2-year data. Within few years, we will definitely get better and better results by witnessing more seasonal cycles and keep on improving our system forecast performance. Thank you for your attention. Here you can reach me with my personal mail or my LinkedIn profile. And now we can move on to the live discussion. Thank you for your attention once more.